this video, we will be doing exercise 7.10 solutions. This exercise is completely about the definite integral with substitution. So we will be doing few fantastic questions in this exercise, which are frequently asked in CBSE board examinations. So let us start with the exercise. As we can see, this is such a simple question. We can do it in a normal way, and then we will substitute the limits. So I can assume here x squared plus 1 is equals to t. On differentiating with respect to x square derivative is 2x into dx is equals to dt. So now x dx is there in my question. This is dt divided with 2. There is one very important thing which you must learn in this question. When you are changing the variable of the question, you must change the limits as well. So these are the values of x which are given. These are the values of x. And I am changing my question to t. So these values should be of t now. If I put x is equals to 0 here, I will get t as 1. If I put x is equals to 1, I will get t as 2. And x dx, this numerator will become dt divided by constant, always keep outside. And this is t. So integration of 1 upon t is log t. And then put the limit 1 to 2. Now we will directly put the values half. First, I will put log 2, then in between minus, then log 1. Few students think that I will keep log aside and I will put the value here simply 2 minus 1. But that would be wrong step, because log and t are not two different values. This is only single value. So when the value is single, so you have to take it separately as I have done. And log 1 we know is 0. So answer will be half log 2. This is the answer. In this question, I cannot solve it unless I remove sine phi from it. So let us first assume that sine phi is equals to t. On differentiating with respect to t, we have derivative of sine phi is cos phi, d phi is equals to dt. As I told you in the previous question also, these values which are given in the question here, these are the values of phi. But when I'm substituting, these will be the values of t. So if I put phi as 0, sine 0 is 0. If I put phi as pi by 2, sine pi by 2 is 1. So I've changed the limit completely. Then I have taken sine phi as t. So this value will be root t. Then I have cos power 5. Since 1 cos phi d phi will become dt, so I'm left with cos power 4 phi. Right? I can write cos power 4 phi as cos square phi ka whole square. And cos square phi is 1 minus sine square phi, iska whole square, right? And sine phi I have taken as t. So my question will become under root t, and 1 minus sine square phi means t square and the whole square. We will open the bracket first. So it will be 0 to 1 under root t a minus b whole square. So that is 1 plus t power 4 minus 2t square into my dt. So this value will be 0 to 1 root t into 1. This is root t plus t power 4 plus half. That will be t power 9 by 2. Then minus 2. 2 plus half, t power 5 by 2 into my dt. Now we can separate this and integrate it separately. 0 to 1 root t dt plus 0 to 1 t power 9 by 2 dt minus 2 is constant, 0 to 1, t power 5 by 2 dt. So t power half, I can take as half plus 1. That means 3 by 2. And multiplying with the reciprocal 2 by 3. And taking the limit as 0 to 1. Then t power 9 by 2. If I add 1 to it, it will become 11 by 2. And multiply with 2 by 11. And the limit is 0 to 1. Minus 2. T power 5 by 2 plus 1, it will be 7 by 2. And multiply with 2 by 7. So the limit is 0 to 1. Now this is 2 by 3. If I put t as 1, so 1 power 3 by 2 is 1, minus 0 will be 0. So into 1 ho gaya, plus 2 by 11. This will also be 1, minus 4 by 7 into may 1. Now if I take LCM, LCM will be 3 into 11 into 7. This will be the LCM here. Now on solving it, I will get, this will be 2 into 11 into 7 plus 2 into 3 into 7 minus 4 into 11 into 3. So on solving it, this value will become 154 plus 42 minus 132 divided by 3 into 11 into 7. On solving, this will become 64 upon 231. That is the answer. Let, in this question, again the substitution, let us assume that x is equals to tan of theta. So dx, if I substitute, dx will be sec square theta d theta. So now, if in this question I have, if I put x as 0, so tan 0 is 0. If I put x as 1, so it will be 45. It means it will be pi by 4. The limit is changed now. Now this is sine inverse. This is 2 tan theta upon 1 plus tan square theta into dx की value sec square theta d theta. Try to understand these steps. You will never commit mistake in solving these. 0 to pi by 4 sine inverse, and this is sine of 2 theta into sec square theta d theta. Now sine and sine inverse will cancel. This will be 2. 0 to pi by 4 theta into sec square theta into d theta. ये हो गया. अब इसमें आप क्या कर सकते हो, जब प्रोडक्ट ऑफ टू फंक्शंस आता है तो हम बाई पार्ट्स इंटीग्रेट करते हैं. सो बाई पार्ट्स में हमें नॉर्मली हम आइलेट रूल के हिसाब से फर्स्ट और सेकंड फंक्शन हम डिसाइड करते हैं. सो दिस इज द अरिथमेटिक फंक्शन एंड दिस इज द ट्रिग्नोमेट्रिक फंक्शन. सो आई एम मार्किंग दिस एज फर्स्ट एंड दिस एज सेकंड फंक्शन. सो अकॉर्डिंग टू रूल बाय पार्ट्स, फर्स्ट फंक्शन एज इट इज, integration of second minus integration derivative of first integration of second. This is the rule of by parts. Now we will be applying here. This will be 2. First function as it is, integration of sec square theta. The limit is 0 to pi by 4. And here also the limit will be 0 to pi by 4. And minus differentiation of first function, derivative of theta, integral of second function, and then d theta. And the limit is 0 to pi by 4. So this will be twice. If I put theta as pi by 4 and minus 0, so it will be pi by 4 only. Right? Because मेरे पास theta और pi by 4, 0 to pi by 4 है ना, तो थीटा की जगह पाई बाय 4 रखेंगे, बीच में माइनस लगाएंगे, फिर 0 रखेंगे. सो इन दिस वे. नाउ sec square theta derivative is tan theta and this is 0 to pi by 4 minus, अब यहाँ पर 0 to pi by 4 तो है ही, डेरिवेटिव ऑफ थीटा इज वी नो 1, Sec square theta is tan theta. So this is tan theta into d theta. So this will be 2. This will be pi by 4. And this will be tan pi by 4 minus tan 0. Then minus derivative of tan theta is log of sec theta. So this will be log of sec theta. And the limit is 0 to pi by 4. This is very simple. Just listen carefully and then practice after that. ठीक है, जो भी क्वेश्चन सुनते हो उसको प्रैक्टिस किया करो सो दैट आपको समझ में आ जाए. tan pi by 4 1 होता है, tan 0 0 होता है, माइनस अगेन log sec pi by 4 minus log sec 0. So this will be 2 into pi by 4 minus sec pi by 4 is root 2. So this is log root 2. Sec 0 is 1. Sec 0 is 1. So minus log of 1. So this will be 2 into pi by 4 minus, we know log 1 is 0. So this is log root 2. Log root 2 may be written as log 2, half log 2. Because we know the property of log. Log says when I have 2 power half into log, so it becomes half log 2. Property of log I have used here. So answer will be pi by 2 minus log 2. In this question, I cannot integrate properly until I remove this x plus 2. So I can do one thing. I can substitute, I can replace x plus 2 with t. So on differentiating, whenever I substitute, I always have to differentiate. Derivative of x is dx, suppose, and dx is dt. So very important is to change the limit, because students सबसे ज़्यादा गलती इसी चीज़ में करते हैं. और मैं हमेशा यही देखती हूँ, बच्चे बोर्ड एग्जाम में पूरा क्वेश्चन ठीक करके आते हैं लेकिन लिमिट चेंज नहीं करते, तो दे डू नॉट गेट मार्क्स. सो प्लीज जस्ट follow these simple things which I'm trying to tell you in a simple way. Now, if I put x as 0, my t will be 2. If I put x as 2 here, my t will be 4. Always change the limit. This is the first and foremost thing. And dx will be replaced with dt, and x is replaced with t minus 2 square root t. Now everything is converted to t. Now you can integrate. So if I multiply inside, this is 2 to 4, this is 1 plus half, this is 3 by 2 dt minus 2, and this is also 2 to 4, and this is t power half dt. Now when you integrate t power 3 by 2, t power 3 by 2 plus 1 is 5 by 2, and multiply with 2 by 5. The limit is 2 to 4 minus 2, t power half plus 1. This is 3 by 2, and multiply with 2 by 3. And the limit is 2 to 4. So I have to solve it. Just see carefully how to handle the powers in fractions. So first, 4 in place of t, it is 4 power 5 by 2 minus 2 power 5 by 2. Like this, minus 4 by 3, and this will also be 4 power 3 by 2 minus 2 power 3 by 2. So to handle these fractions, first try to understand, when something upon 2 is written, it means square root, and inside is 4 power 5. 4 power 5 स्क्वायर रूट से बाहर तो पेयर्स आते हैं, 4 5 टाइम्स अंदर है, तो इसका मतलब क्या होगा? We can do here, to simplify it, 2 power 2 I can write 2 power 2 into 5 by 2 minus 2 power 5 by 2 is square root 2 power 5, and that is 2 is happening 5 times inside. So अगर हमारे पास 2 5 बार अंदर है तो pairs हमारे बाहर आते हैं, we know this. So this and this will come out, that means it will be 4 root 2. So please note down, it will be 4 root 2. How I have solved it here, minus 4 by 3, and 4 power 3 by 2 is 2 power 2 into 3 by 2 minus 2 root 2, because 2 power 3 by 2, I solved here root 2 power 5. You can solve it 2 power 3 by 2 in the same way. So this is 2 power 5, 2 by 5, and this will cancel. So this will be only 2 power 5, means 32 minus 4 root 2. This is 4 by 3, and this will be 8 minus 2 root 2. Now 2 by 5 into 32 minus 8 root 2 upon 5 minus 32 upon में 3 plus 8 root 2 upon में 3. Now, if we look at these, we can take LCM as 15 in both of these. So it will be 6 into 32. 6 into 32 minus 32 into में 5. And here also LCM is 15. This will be 40 root 2 minus 24 root 2. So 40 minus 24 is 16 root 2 upon में 15. And this is 32 upon में 15. So we can take 16 common here. 16 upon 15 we can take common here. So this will be 2 plus root 2. This is the answer. In this question, we have cos x as t. Let cos of x is equals to t. If I differentiate, derivative of cos x is minus sin x dx is equals to dt. So the very first thing, change the limit. Cos 0 is 1 and cos pi by 2 is 0. And sin x dx is dt upon 1 plus t squared. Now, integral of 1 upon 1 plus t square is tan inverse t. Minus was there. So it is tan inverse t, and put the limit 1 to 0. Minus, first I will put tan inverse 0 minus tan inverse 1. Tan inverse 0 is 0 and tan inverse 1 is pi by 4. So our answer for this question will be pi by 4. In this question, we can see here, we can complete the square because factors तो यहाँ पर नहीं बन रहे हैं. अगर factors बनते हैं तो हम partial fraction लगा देते हैं. Square complete करके हम formula लगा सकते हैं. तो square complete करने के कुछ rules हमने 7.4 exercise में सीखे हैं. Constant को मैंने बिल्कुल पहले साइड कर दिया, और जो बाकी दो टर्म्स थी, ये वाली टर्म और ये वाली टर्म, इन दोनों टर्म्स में मुझे एक्स स्क्वायर पॉजिटिव चाहिए, तो मैं माइनस को बाहर ले लेती हूँ, एंड दिस विल बी एक्स स्क्वायर माइनस एक्स, लाइक दिस. वेरी इंपॉर्टेंट स्टेप इट इज. उसके बाद हम कभी भी इन क्वेश्चंस में माइनस को कंप्लीटली बाहर नहीं लेते कि हम सोचें हमें एक्स स्क्वायर प्लस चाहिए, चलो माइनस कॉमन ले लो. नो, माइनस को कंप्लीटली बाहर नहीं लेना है. इट इज नॉट अलाउड व्हेन यू आर अप्लाइंग द फॉर्मूला इन दीज क्वेश्चंस. देन टू कंप्लीट द स्क्वायर वी नो द रूल कि एक्स वाली टर्म के साथ हमें 2 चाहिए, बट 2 तो है नहीं. सो मैंने क्या किया, 2 से मल्टीप्लाई एंड डिवाइड कर दिया. इंपॉर्टेंट स्टेप. उसके बाद 2 और x को छोड़ दीजिए. 2 और x को छोड़ने के बाद जो टर्म बचती है, मैंने 2 और x को छोड़ दिया तो मेरे पास 1/2 बचा. तो 1/2 का मैंने स्क्वायर ऐड करना है और उसका स्क्वायर मैंने सब्ट्रैक्ट करना है. कंप्लीटिंग स्क्वायर का ये रूल होता है. 7.4 वाली वीडियो खोलकर देख लीजिए, आपको समझ आ जाएगा कि मैं क्या बोल रही हूँ. वहां पर हमने डिटेल में डिस्कस किया है इस मेथड को. दिस विल बी 4 minus, and now I can take these 3 terms all together as x minus 1/2 का whole square minus 1/2 का whole square, like this. So this will be 0 to 2 dx upon, अब आप ये देखो, ये 1/4 है, ये माइनस और ये माइनस क्या बन जाएगा, प्लस. 4 plus 1/4 that will be 17/4, right? अब इसको हम 17/4 लिख लेते हैं पहले, फिर आप कंफ्यूज हो जाओगे, नहीं तो सारे स्टेप्स इकट्ठे कर दिए. तो इसलिए ये अगर आपको समझ में आता है तो आप डायरेक्टली भी जो नेक्स्ट स्टेप है वो कर सकते हैं. 0 to 2 दिस इज dx अपॉन, बिकॉज 17/4 नहीं चाहिए मुझे, किसी नंबर का स्क्वायर चाहिए, तो मैं इसको √17/2 का स्क्वायर कर सकती हूँ. वेरी सिंपली आई कैन राइट इट एज √17/2 का स्क्वायर. माइनस x माइनस हाफ का स्क्वायर। हमने 7.4 एक्सरसाइज जो की है तो उसमें हमने बहुत सारे फॉर्मूले किए हैं और उसमें से एक फॉर्मूला हमने ये भी किया था, इंटीग्रल ऑफ dx अपॉन a स्क्वायर माइनस x स्क्वायर। द फॉर्मूला वाज 1/2a log of a plus x upon a minus x. So we will apply this formula here. This will be 1/2a. A is root 17/2 log of a plus x. So a plus x upon a माइनस एक्स। बी वेरी केयरफुल, माइनस है तो मैं माइनस लगा रही हूँ, तो जो दो प्लस के हैं उनके साइन चेंज हो जाएंगे, तो एक्स जो प्लस का है वो माइनस हो जाएगा और जो हाफ माइनस का है वो प्लस हो जाएगा, ऐसे। एंड देन वी पुट द लिमिट 0 to 2. Be very careful. So this and this will cancel. Do it very carefully. Definitely you will get the answer. There won't be any problem. This will be log. Now if you take the LCM here to simplify, this will be root 17 plus 2x minus 1. And this will be root 17 minus 2x plus 1. Now we will put the limit 0 to 2. Now in this case, if I put the limit 0 to 2, this will be 1 by root 17 outside, inside. If I put 2 in place of x, then this will be 4. 4 minus 1, 3. So I can write it as root 17 plus 3. If I put 2 here, minus 4 plus 1, minus 3. So root 17 minus 3. फिर minus, I will have log. If I put x as 0, it will be simply root x minus 1 upon root 17 plus 1. Like this. Log a minus log b होता है log a upon b. So it will be log root 17 plus 3 upon root 17 minus 3. अपॉन है तो अपॉन को हम रेसिप्रोकल भी कर सकते हैं, रूट 17 प्लस 1 अपॉन रूट 17 माइनस 1. आपको आई होप समझ आ गया होगा, बिकॉज लॉग ए माइनस लॉग बी होता है लॉग ए अपॉन बी. सो डिवाइड को मल्टीप्लाई में करना है तो रेसिप्रोकल ले लेते हैं. यू आर इन 12th, तो आपको पता ही होगी ये चीज. अब हम इसको मल्टीप्लाई कर लेते हैं. सो दिस विल बी 1 by root 17 log. Now multiply the terms. Root 17 will become 17 plus 3 root 17 plus root 17. It will be 4 root 17 plus 3. And here this will be root 17 minus 4 root 17 plus 3. Now this will be 1 upon root 17 log 20 plus 4 root 17 upon 20 minus 4 root 17. So we can rationalize it to have our answer. Here I can see 4 is common here. So मैं 4 दोनों से common ले लेती हूँ. This will be 5 plus root 17 and this will be 5 minus root 17. Now I can rationalize 5 plus root 17 and 5 plus root 17. Multiplied and divided. This is 1 upon root 17 log of 5 plus root 17 का whole square. So a plus b का whole square 25 plus 17 plus 10 root 17 divided by 25 minus 17. So this will be 1 upon root 17 log of, so this will be 42 plus 10 root 17 upon 25 minus 17, this will be 8. So this value will become 1 upon root 17 log of 2 is common, 21 plus 5 root 17 upon में 4. That is our answer. Here I have x square plus 2x plus 5. I can easily complete the square here. So this will be dx upon x square plus 2 into 1 into x. X वाली term में हमें 2 चाहिए होता है, so 2 is already here. So 5 I can write as 1 plus 4. Right? These 3 will become minus 1 to 1 dx upon x plus 1 whole square. Plus 4 I can take as 2 square. We know the formula integral dx upon x square plus a square. The formula is 1 upon a tan inverse x upon a. So 1 upon a tan inverse x upon a. Now put the limit minus 1 to 1. This will be half. Now first I will put x as 1. So this will be 2 upon 2 means 1 minus tan inverse minus 1 plus 1 will become 0. So it will be 1 by 2. Tan inverse 1 is pi by 4 and tan inverse 0 is 0. So my answer for this question is going to be pi by